In this problem, we're asked to find the domain for the function f, which is a root. It's the square root of x squared minus 30x. And again, when we think about domain questions, the main thing we're after here is trying to find the set of values that the function can handle. In general, a function can handle usually a large number of values, but perhaps not all values. And so our goal in this problem is to figure out exactly which ones can it handle. Often we think about these problems in terms of what it cannot handle, and what we will do in this problem is figure out what needs to happen or what cannot happen, depending on which way you want to view this, so that this function will be able to return a value. The structure of the individual functions plays a large role in this investigation, so we need to know a little bit about the building blocks for these functions. If I look under the root, first of all, x squared minus 30x, that can handle anything. I can put any value I want in for x and square it, subtract 30 times that value, and I will get a number back. There are no problems in doing that calculation. But the result of that calculation, then, it gets placed under the root, which means we need to find the square root of whatever value is returned by that x squared minus 30x. And that's where we can run into some trouble. The square root, being an even root, cannot handle negative values. Turns out 0 is fine. If this quantity turns out to be 0, the square root of 0 is 0. And positives are fine. If this quantity turns out to be a positive number, the square root of a positive number is another number. But the square root of a negative number is not real. It is complex, but we are looking for real values coming out of this, and a real number will not come out. Other roots share this, but not all of them. Odd roots, if we were taking the cubed root or the fifth root or the seventh root, etc., there is no domain restriction. Any value can be handled. So one of the things we need to notice is that this is an even root, a square root, or a fourth root, or a sixth root, etc. Any of those cannot handle negative values. You cannot square a negative value and get something positive. So the investigation I would undertake here now is to ask myself, what is the sign of x squared minus 30x? And of course it's going to vary depending on what x is typically. So I would ask myself, for example, when is x squared minus 30x greater than or equal to 0? This will then give me a set of values for which the root can return a value. I could write this problem in the negative sense, saying when is x squared minus 30x less than 0. That will tell me which values this function cannot handle, and then I can use that to construct my domain. Either approach is fine, and in terms of the work, they're virtually identical. So this time, since I've already written it out, this is the way I'll approach it. I'm asking myself, when is x squared minus 30x greater than or equal to 0? Now again, this is an inequality, but we've seen quadratic inequalities before. The approach on these typically is to rewrite this left-hand side as a product. In other words, factor it if we can. And I immediately notice that this an x will factor out. So this factors fairly quickly. If I factor an x out of x squared, I get x. If I factor an x out of minus 30x, I get minus 30. So the problem that we posed for ourselves is equivalent to this problem here, which is a product. Now, there is a real temptation here to try and break this into two problems. And although it is possible, it's a place where errors are often made. So you got to be take care if you go that route. We cannot simply say that because we want the product to be greater than or equal to 0, that we must have x greater than or equal to 0 and x minus 30 greater than or equal to 0. That's a very common misconception. In fact, in order for the product to be greater than or equal to 0, we either need both of the terms in the product to be positive or both of the terms to be negative. And that's the negative piece that tends to get lost if you approach the problem by writing it as sets of inequalities. a more effective in terms of less likely to make mistakes, and even efficient in terms of getting the solution quicker, is to write out a number line that involves the terms in the product, the signs. We don't actually need specific values, but the signs of this up on top, and the numerical values of x that we're placing into this product down below. And what we'll do is just catalog our findings. There are places where this will be 0. In fact, let's put those on right now. This will be 0 if x is 0. So when x is 0, the product will be 0, since the first term is 0. And the product will be 0 when x is 30. And more importantly, or just as importantly at least, there are no other values of x that will give rise to a 0. Everywhere else we will either get a positive number out or a negative number out. And again, that sign can vary, but it can't vary too much. For every value of x larger than 30, the sign that goes up here must be the same. If it changed, so let's talk about the logic behind that statement a little bit. If it did change, the only way it could change is by going through 0. So if you had something that was slightly positive on one side and slightly negative on the other, for example, then in between there must be a 0. And we know that there are no zeros out in here. So if it's positive for any value of x out here, then it's positive for all values of x. And similarly, if it's negative for any value of x, then it's negative for all values of x. So we've now reduced this investigation into looking into 3 regions. What's going on above 30, what's going on between 0 and 30, and what's going on to the left side of 0. Once we have these signs, we can then answer the question we've posed for ourselves, which we've already talked about, the fact that that's directly related to the domain of the function. So out in here, I'm viewing this as a product of 2 numbers, so rather than going after the values themselves, let's just look at the sign. If x is a number bigger than 30, any number you like, what is the sign of x? Well, clearly it's positive, since it's bigger than 30. And then ask yourself, what is the sign of x minus 30? So if our number x is larger than 30, and I subtract 30, what will the result be? And again, it's easy to convince yourself that it would be positive. So for every x greater than 30, this product will be the product of 2 positive numbers, which is positive. All right. Again, we'll return this to the domain question after we investigate these other regions. So let's continue on in here. If my value is between 0 and 30, my value for x is between 0 and 30, then again, let's just look at each term in the product. The first term will be positive, because my number is between 0 and 30. Those are all positive. But if I subtract 30 from the number, since my number is less than 30, when I subtract 30, I'll end up with a negative value. So in this region, the number that I will get out will be the product of a positive and a negative, which we know to be negative. So in this region in here, the product is negative. If I look to the left side of 0, again, I'm looking at the product of 2 numbers, x and x minus 30, and I'll just investigate the signs of those 2 pieces. Since x is less than 0, the x term will be negative, and since the x is negative and subtracting 30 will also make it negative. But notice in here, we've got the product of 2 negative numbers.